When people join a queue faster than they can be served, a line has formed. Lines soon get much more complicated. Breaking a line down into simple parts becomes easy with Kendall's notation, popularized by David Kendall in the early 1950s. Kendall's notation breaks down the queue into 5 main variables: A, B, C, D, and E. The 5 values are substituted with characteristics of that specific line. Here's an example, but what do the variables mean? Let's start with A. A is how people join the queue, while B is how they're served to leave the queue. The A variable is commonly M for Markovian. This is when the arrival rate is random but can be determined somewhat with probabilities or averages. D is for deterministic. The arrival and/or service rate is fully fixed and the same every time. G is for general. No assumptions can be made whatsoever about the arrival or service rate. This is rare in typical lines. The C in Kendall's notation is how many servers are in the queue, such as the number of cashiers at a checkout line. It's typically an integer. The D value is the overall capacity of the queue, which is typically infinite. Finally, E. E is the queue's discipline, or how the people are served, most commonly first come, first serve. Here's a grocery store. The people arrive to the checkout at varying times and are served for various amounts of times. There are 3 servers in this queue. Because the arrival and service rates vary, they are both M for Markovian, and C is 3 because there are 3 servers. The D value is infinite because an infinite number of people can continuously go through this line, and the E value is first come, first serve, as most typical grocery stores are. The D value being infinity and the E value being first come, first serve are the standards, which means they can be omitted, so this line is either MM3 or MM3, infinity, first come, first serve. There is no better place to study lines than at Disney World, where they get as complicated as they can be. Using Kendall's notation helps simplify these difficult lines. For example, at a ride at Disney like the Tower of Terror, guests arrive at varying times, but typically at peak times of the day. The service rate of this line is the same each time, as the ride is the same amount of time for whoever rides it. Finally, there are 4 elevators people can ride, which means the queue has 4 different servers. Therefore, the Tower of Terror is an MD4 line. Kendall's notation answers the 5 questions we were all wondering. How do people enter the queue? How do they get served? How many servers? What's the customer limit? And how are the customers served?